This is the solution video for section 7.4, problem number 9. Alright, so the graph of the function f above consists of 3 line segments. So we see the graph of f up here. A says, let g be the function defined by g of x equals the definite integral from -4 to x of f of t dt. Alright. For each of g of -1, g prime of -1, and g double prime of -1, find the value or state that it does not exist. All right, so first of all, g of -1. All right, so this is part A. All right, g of -1, function notation. G of x is the definite integral from -4 to x of f of t dt. So g of -1 is the integral from -4 to -1 of f of t dt. All right, so what does that mean? Okay, so the integral from -4 to -1 of f, this is the graph of f, so integral from -4 to -1 is representing the area of underneath that curve, right? So this is an area that is below the x-axis, so ultimately this area is some negative value, right? So we need to find the geometric area and then make it negative, all right? So I'm going to put a negative in front. All right, what is the geometric area? Well, this is a trapezoid, so I'm going to take half of the width. So I go from -4 to -1, so that's a width of 3, times the base. So the base on the left is -3, plus the base on the right, which is -2. Now remember, okay, I want to call those negatives, but I've already dealt with the fact that they're negative. So I'm just taking that distance of 3 plus the 2, right? Because otherwise we would have gotten a positive value overall, right? So I have half of 3 times 3 plus 2, right? So 5 times 3, 15. So -15 halves is the value of g of -1. All right. So next, g prime of -1. All right. So now we need to think g prime of x first of all. All right. So remember, given the second fundamental theorem of calculus, if g of x is defined this way, then g prime of x is found by taking x and putting it in place of t. So actually, g prime of x is simply f of x times the derivative of x, which is just 1. So g prime is f. So this is a graph of f, which is also a graph of g prime. And so if I want to know g prime of -1, then I'm looking at this graph. Where is this graph when x is -1? And that value is -2. So g prime of -1 is -2. All right, now g double prime of -1. Now, if this graph is g prime, then g double prime is the slope of this graph, or the derivative of this graph. So what is the derivative of this graph at x equals -1? Well, we would say that that value does not exist, right? It said state that it does not exist if it does not exist. So why does it not exist? Well, because this point represents a corner point. The derivative from the left of -1 is not equal to the derivative from the right of -1. All right, so that's part A. All right, so now part B. All right, so part B says, for the function g defined in part A, find the x-coordinate of each point of inflection of the graph of g on the open interval -4 to 3. So open interval, remember, obviously between -4 and 3, and it says explain your reasoning. All right, so starting to explain our reasoning, we think about what does a point of inflection mean. All right, so a point of inflection, so this is really a Unit 4 question, but obviously in a Unit 7 question. So a point of inflection on G. Okay, so it's very important that we use the correct names here. Point of inflection on G means what? Means that g double prime changes sign. Now, g double prime is the slope of g prime. So what we're saying is the slope of this graph changes sign. So where does the slope of this graph change signs? Well, positive slope, negative slope. So the slope changes at x equals 1. All right, and so point of inflection on g means that g double prime changes sign. G double prime is the slope of g prime. So at x equals 1, right? That is our justification. That sentence, or those sentences there, is our justification of a point of inflection on g being at x equals 1. All right, so that is part B. All right, part C. All right, let h be the function given by h of x equals the definite integral from x to 3 of f of t dt. Find all values of x in the closed interval -4 to 3 for which h of x equals 0. All right, so this is kind of an interesting question. All right, h of x is the definite integral from x to 3 of f of t dt. So the integral from x to 3 of f of t dt. All right, now remember, 3 is the right-hand endpoint, right? And so we don't want to change this and put x on top necessarily, because we're thinking about the integral from some number to 3, right? Now, the first one to think about is the easiest one, right? If x is 3, right, then the integral from 3 to 3 is equal to 0, right? That's what we're looking for. When is h equal to 0? So we can say that h of 3 is equal to the integral from 3 to 3 of f of, that should be f of t dt, right? So f of t dt, right? Well, of course, that's 0, right? So that's easy. So h of 3 is 0. So it says, find all values of x. So h of x equals 0 at x equals 3. All right, so that's one answer. All right, now, what are we saying here? The integral from x to 3 equals 0. So now let's take a look at the graph. All right. So let's go backwards. How about from 2 to 3? What is the integral from 2 to 3? Well, the integral from 2 to 3 would be this value, right? This is a negative area, right? That's a negative number. It's not 0. So that's not one of our answers. Now, keep going back. What about the integral from 1 to 3? That would be this area plus this area. But remember, this area is negative, right? And this area is positive, and they are equal in size. And so they would cancel each other out. So that means that the h of 1 would be the integral from 1 to 3 of f of t dt, which is also 0. So x equals 3, x equals 1. All right, and then we go on and we keep working backwards. All right, so now if we look at the picture, we work backwards. Now I go back to 0. How about? So now I have this area and this area together minus this area. Well, obviously that area from 0 to 2 is larger than from 2 to 0. Keep going backwards. Now this area is actually the same as the integral from 0 to 1, the same as the integral from 1 to 2, and the same as the integral from 2 to 3. And so we can say that the integral, so h of -1 would be the integral from -1 to 3 of f of t dt is also 0, because the sum of the areas from -1 to 3 is 0, right? These two are negative, and then these two are positive. All right? Now, if you keep going backwards, these are only negatives, and there's never any positives to get rid of those, and so these are the only values, -3, 1, and -1. All right, so that's C. All right? D, for the function h defined in part C, find all the intervals at which h is decreasing. All right, so I'm going to go over here, all right, for D. All right, so h is decreasing. So let's think about this in terms of unit 4. When is a function h decreasing? Well, that is when h prime is less than 0. H prime is less than 0, right? All right, so h is decreasing when h prime is less than 0. So then we need to find out what h prime of x is. All right, so we are told that h of x, right here, h of x is the definite integral from x to 3 of f of t dt. But remember, according to the second fundamental theorem of calculus, we cannot take the derivative of this unless the x is on top. And so now we need to flip the limit. So I have 3 to x of f of t dt, and that means that we put a negative in front. So now, what is h prime? So I have the negative in front. Okay, now the derivative would be found by putting x in for t, so f of x times the derivative of x, which is 1. So in other words, h prime is the opposite of f of x. Or if you think about it this way, h prime is found by taking and reflecting f over the x-axis. So, quick little sketch of f. Okay, everything that's below the x-axis is now above the x-axis. So I have this, and everything that's above is now below. So this is the graph of h prime, right? All right, and so the question is, find all intervals for which h is decreasing. What does that mean? That h prime is less than 0. So in other words, when is this graph below the x-axis? So h is decreasing when h prime is less than 0, so on the interval 0 to 2. All right, and so that is part D.